All right, good day, everybody. Wherever you are, I'm so happy and I'm so excited to be bringing this to you. It's a very, very big package from CMRC, Creative Mind Real Concept. And I'm most privileged to be the innovator, the initiator of this program. It is a very, very big success to bring this to you. Free Success Project 2025. And this year, I am so happy. We have amazing facilitators, persons who are selfless, who are passionate, who are explicit in every ramification of their discipline, and they will blow your mind. So I want you to keep your tabs and start watching these videos and get excellent results and come back to tell us, and we'll rejoice with you. God bless you.
Okay, so once again, my name is Unavailable Miracle, and the initiative is CMRC, Creative Mind Real Concept. So, we're going to equation of motion now, which is a very common thing among secondary school students and science students actually. So, and I want to talk about the three main ones that we'll be using. The first one is V equals to U plus AT. The next one is V square equals to U square plus what plus 2AS. Then we have another one which is the S, and I'm going to explain what each of these letters is standing for. We have UT plus half what AT square. Now, these are three equations which you'll be using you have been using this, so it's not that way you'll be using it. You have been using them. Now, let me just tell you the tricks to them. If you have a question on motion, one is asking you, maybe they're asking you to calculate velocity, and in that question you are given the initial velocity, which is u, and you are given a, which is the acceleration, and you are given t, which is the time. You know that the best formula to use in that kind of situation, whereby you only asked to calculate the final velocity, is what? Is this. For example, they tell you that, okay, a car initially in motion with a speed of 20 meters per second, initially in motion, that means the initial velocity is what? 20 meters per second. Moving with an acceleration of 0.5 meters per second, acceleration of 0.5 meters per second square. And now say that what is the velocity after 7 seconds? What is the velocity after 7 seconds is standing for the final velocity, which means I'm looking for what? For V, but my time t, which is 7 seconds, has already been what? Been given. Now, see something. I have my u, which is initial velocity. I have my acceleration, which is 0.5 meters per second square. I have my time, which is what? 7 seconds, but I don't have my final velocity. Now, which formula goes best? Which is this what? This one. I have u, I have a, I have t, but I don't have what? V. So I just slot it in. Also, let's assume I was already given my u. I was already given u. And the only thing I don't have is the time. Maybe they're asking me for the time it takes to get to so velocity. That's when so velocity is what? Is 50 meters per second, and I'm asked to calculate the time. Look at this kind of scenario too. The only thing I'm lacking from this equation is what? Is t. The rest have already been given. V is there, U is there, A is what? Is here. The only thing I need is t, and it's in the formula. So I use that formula. But let's assume I'm asked to calculate distance. From this same question now, I'm giving my initial velocity, I'm giving my final velocity, I'm giving my acceleration, but I don't have time. And I'm now asked to calculate distance too. Which one do you think is the best? Definitely this one. Because if you look at the second equation, I have my final velocity, right? Yes. I have my initial velocity, yes. I have my, my acceleration, yes. And I'm asked to calculate what? Distance. So I use this the second equation. Then, for the third one too, I might want to consider it, but look at something. Am I given time in the question? No. Time is unknown, Abby. So that means this third equation is not suitable, although I'm looking for what? Distance. So whenever you are trying to solve any question, try and make sure that all the parameters that are given in the question, even those that are not given directly. For example, they will tell you that, okay, a body is moving from rest. A body is moving from rest. Nobody will tell you that your u is equal to 0. You are supposed to know that, okay, from rest means is initially at what? At rest, and the initial velocity is going to be what? 0. So all you just have to do is when you look at the question, read through it, then what? Gather all the necessary parameters and what? And put it into the formula that fits best. So you don't just write the formula and start working with it. No. You look for the parameters. Do I have all the parameters in this formula? Am I left with just one unknown? If that is the case, then that formula is what? Is the right one to use. And if that is not the case, whereas you have like two unknowns in the formula, then I'm telling you that that's not the right formula. Go for another one. So with that, I think we can move to what we call the graphical aspect of this, which is the explanation of graphs. And sometimes they can give you questions in graphical form, or you have to interpret your questions in what? In graphical form. I think the commonest form in which they can bring up question in this is to ask the question based on velocity, acceleration, deceleration. So see, if I'm given a displacement or distance time graph, this x is standing for both distance and what? And displacement. So it can be used interchangeably. You know, I already told you that when it is distance, we're talking about the scalar part that only has magnitude. When it's displacement, it has what? Direction and magnitude together. Now, if you are given a displacement time graph, this is what we call the displacement time graph, xt graph. Now, given this kind of graph, this is going to be time in seconds, and this is going to be distance or displacement in mostly the SI unit, meter. Now, if you have a straight line like this, a straight line, a positive slope like this that is straight, what we are having here as a slope is what we call the what? The velocity. Slope equals velocity. The slope of this graph like this is representing what? Velocity or what? Or speed. Yeah. It will be speed if this place is representing distance. It will be velocity if this place is representing what? Displacement. And this is a what? This is a uniform velocity because it's a straight line. And you can also have it to be in form of like maybe something curved. X in meters and t in what? In seconds. Something like this. And you will still get the what? The slope. It will be like a straight line tangential to the what? To the curve. Now if you get that, the slope of this will still be representing what? The slope will still be representing either speed or what? Or velocity. So either way, or you know that whenever you have what's it called? The displacement on the vertical or the distance on the vertical, and you have the time on the horizontal, the slope of that graph is going to be velocity or what? Or speed, depending on what is on the vertical axis. So that's for displacement time graph. We have another one called the velocity time graph. Now for the velocity time graph, this is where you have to pay more attention because it's very, very, very common. So for the velocity time graph, what are we having on the vertical? We're having our velocity in meter per second. And it can also be speed, but most of the time is always what? Velocity. On the horizontal, we're having what? Time. In what? In seconds. Now, look at this one. I'm going to like make it a combined graph. See, if you have a straight line like this, straight line like this, the slope of this place, let's call it slope 1, is going to be what? Acceleration. Are you with me? Now, if you have a straight line graph like this, if I'm to draw it separately, this is how it's going to look like. Like this. If you have a straight line graph like this place is going to be representing what we call what? The slope 2 is going to be representing constant velocity. Or you can also say it is equal to what? Or you can say or zero acceleration. Are you with me? For the first one, I'm having a what? A uniform acceleration, Abby. Meaning the velocity is increasing at equal time interval with the what? With the time. As velocity is increasing, the time is increasing. But when it gets to this place, the velocity is no more increasing, it's just remaining constant. Whereas the time keeps what? Increasing. So during this phase of a straight line, this straight line, I'm having what? I'm having a constant velocity. I can say I'm having a what? A zero acceleration. Now I can have another one that will look like this. That will look like this. That will be a negative what? A negative uniform slope like this. If I'm to draw it separately, it's going to look like this. Something like this. velocity in meter per second, then time in what? In seconds. If I'm having something like this is also an acceleration, but acceleration in the negative direction. That is the negative acceleration, or which you also call what? Deceleration. Most of the time, people, when I calculating, you always get like something like minus maybe 0.5 meter per second, and you'll be like, the acceleration is supposed to have minus. Yes, it can have minus. And the minus is saying that this thing is what? Is slowing down. It's just like when your daddy wants to like park his car. Whenever he applies brake, what happens? It slows down. But whenever I want to accelerate, when he's trying to accelerate, when he's about to go out in the morning, what happens? His car speeds up. When he's speeding up, that's when you're having what? Acceleration. When he's about to park in the evening, when he's applying brake and he's about to like park his car, what you're experiencing what? Deceleration. Are you getting it? So now, they cannot like do something. They cannot label all these places for you. They can label it as, they can shade this place. They shade this place, they now say, okay, this is A, this is B, this is C, and I say this shaded area is what? Is D. Now tell you to like identify each of the letters. They say you should identify each of the words, each of the letters. Now this is time. A will represent what? Acceleration, right? Then B will represent what? Constant what? Velocity. Then C will represent deceleration. Then D, now that's what I want to talk about the most. D, whenever you have a graph and you are asked to calculate, okay, maybe in mathematics, maybe you have done integration, they will tell you that, okay, calculate the area under the curve or kiniko. Whenever you are asked to calculate area under a curve, especially when it is dealing with something velocity and time. Velocity is on the vertical axis, time is on the horizontal axis. What you are going to be getting as the area of that shape formed by the graph is going to be the distance covered. So you might be given something like that and you have to calculate the distance covered. And you now be like, distance covered. What are they asking me to do? Most of you will go and be doing, okay, get the velocity, get the time, get the everything, then start plugging into the formula of equation of motion. Yes, it might work sometime. Sometimes the answer you will get will be wrong and you still see it in the option. That's UTME for you. But whenever you are given a graph and they're asking you to calculate distance covered, the best thing to do is what? Get the area of the what? Of the shaped form. For example, looking at what I drew here, the shape formed is what? Is a trapezium. And what's the formula for area of a trapezium? That's equal to what? 1/2 A plus B times what? Times H. Where is the A? From this point to this point, that is A. From this point to this point, this point, that is what? B. Why the height of this place, that is from A to A, that represents the what? The height of the what? Of the shape. Now, I've gotten my A from this place to this place. It will be given because they are going to like label the time. Let's say this is T1, this is T2, this is T3. So that means, in fact, let's put value. Let's say this is 1, this is 3, and this is 4. Now, it means that between this point and this point, I'm having what? 3 minus 1, that is 2. That will be 1/2, 2 plus. What about my B? B is from this place to this place, which is what? 4. Then the height, let's assume this place is like 10. So that means the height H is what? Is 10. Then when I do that, I will have what? 6 times 5, which is what? 30 what? Meters. So the area under the curve is what will give you the what? The distance covered. Now, let's quickly talk about motion when, all this motion that we're talking about has to do with what? Horizontal parts now, linear motion. But we can also have linear motion in terms of the vertical direction. And that's what we call the what? Motion of a body under what? Free fall. So now, motion of a body under free fall is not that much. Let me just tell you a small thing, like a very small thing about it. Now, see something. I have a mango that is about to like fall from the tree. Now, if the mango is falling down, what is happening? The mango is being like pushed down. It's being like accelerated downward towards the earth by what? By what we call the gravitational force. So that means in a straight line motion, like when you have a straight line motion in the vertical direction, the main force that is influencing that kind of motion is what we call the what? The gravitational force. And that's why when you jump up, something has to push you down, Abby. Okay. Now, if our motion is now in the vertical direction, like which is under gravity, what are the things that we do? Nothing actually, except small changes. And what are the changes? Wherever you are having your acceleration A, for example, we now this is the equation of motion, where you have v squared equals to Sorry, let's start with v equals to u plus at. Now in this equation now, the only thing you are changing there is what? You are changing your a to what? To g. You are changing a to what? Your acceleration to what? To acceleration due to gravity. They are still both acceleration, but the only difference is that the acceleration here is variable. This one is more of a constant acceleration. It's very, very, very close to being constant. It only varies due to what? Due to position, like your current location. But it's always equal to what? To that g. Now, it can either be positive or negative, depending on which direction, you know. If velocity is a scalar, is a vector quantity, then acceleration should be what? A vector quantity. Meaning, it also depends on direction. Now, if I'm going up, see now, I want to throw this thing up like this, pa. As it's going up, what do you think is happening? It's going against what? Gravity, Abby. So if it is going against gravity, that is upward. Upward means your A will be equal to what? Minus G. So that means if I have my motion to be in the upward direction, my equation here will change to V equals to U minus GT. Where is the minus coming from? From this minus G here. But let's assume maybe my mango wants like, maybe I'm trying to like pluck a mango and the mango is coming down. Like, you know, it's coming from the top, I'll be going down. If that is the case, what do you think happens? I'm having, if it is downward, my A will be what? Positive G. So if that is the case, this same equation will be what? V equals to U plus GT. Minus plus. This is when it's going upward. This is when it's going what? Downward. And now the same thing that applies to the rest too. All the other equations, the only thing that is changing then when it is vertical motion is this. Although there are still some other concepts that we'll still have to talk about when we get towards projectile. Like what happens to velocity at the maximum height and stuff like that. But for now, this is what we have. So with that, I think we can go to what we call the laws of motion. Now, before we go to that, let me tell you something. You know, since I've been talking about motion, I didn't tell you about what is causing that motion. Abby, if you notice when I was defining motion, I didn't add something. I didn't add what is causing it. I just said, okay, it's the change in position of a body due to, change in position of a body from one point to another during a particular period of time. But what is causing that motion? Go. That's what we want to talk about now. Now, the first law of motion now states that all objects in the universe, not only in our earth, in fact, outside the earth, all objects, when we refer to objects in physics, refer to substance, anything, all objects in the world, in the universe, continue in a state of rest or uniform motion. Meaning you can be moving and you say appear as if you are at rest. You know, like motion of the earth now. Even though it's moving, but it's moving uniformly. So all objects in the universe will continue in the state of rest or what? Or uniform motion unless acted upon by an external force. Now, as this board is now, it will continue in this position if nothing touches it. But the moment I give it a slight displacement, what am I using to give it a slight displacement? I'm applying force. So that means there must be something that will cause that motion. Your daddy's car cannot move unless something is supplying the force, which is the car engine. You personally cannot move unless something is supplying the energy, something is supplying the force, which is what? Your internal what? Energy being converted to what? To force, where you are using your what? Your end limb, your all this thing, you know, to create a kind of what? A propelling force to move. So if there is no force, you can't assume there is going to be what? Motion. It's not even possible. Something has to push you. So now, that's the first law. That's what the first law is talking about. If there is no force, no object is going to what? Is to move. Or if you're already moving, you continue that kind of motion unless something comes to you and what? And push you away or apply force on you. Now, for the second law, which is where we are going to like, you know, write one or two formulas again. That is when you say that the time rate of what? Of change in momentum. The time rate of what? Of change in momentum. What is change in momentum? Momentum is what? M times, that is the mass, times what? Times change in velocity. The time rate of that change in momentum, which is momentum over time, is directly proportional to the what? To the applied force. You know, in the first law, we said something said, for we to have motion, there must be what? An applied force, Abby. Okay, so that means whenever I apply force on you, you are going to expect what we call a change in momentum. Your mass multiplied by the velocity I've given to you, which is actually something that brings about the concept of inertia, but that's for another time. Now, I'm having my change in velocity, like rate of change in velocity, proportional to what? To the applied force. If I introduce a constant, I'm going to have my F to be equal to what? Km change in what? In V over what? Over T. Now, remember that when we're doing what's it called? when we're talking about acceleration and everything, I said acceleration is the rate of change of what? Velocity to time. So look at this thing. See this one, velocity over time. Is it not rate of change of velocity? Yes. That means I can see my F is equal to Km times what? Times A, which is what? Acceleration. Now, my constant K is equal to what? Unity, which is what? 1. Now, see something. I will have F equals to 1 times what? MA. That means my force F is equal to MA. Now, that is force, fine. But when it comes to vertical motion, this is for horizontal motion. When it comes to vertical motion, I said my A is always equal to what? G. So if my A is equal to G, I will have my F to be equal to mg. And if it is equal to mg, it's also the same thing as my what? As the weight. Weight of what? Of a body. So in this case, I can say that the weight of a body is the what? Is the force used by the is the force acting on an object, making it to be attracted towards the what? Towards the earth. That is, weight is equal to what? The mass of the body times what? Their value of acceleration due to gravity in that location. Now, moving on, let's move to projectile real quick. You know, we have talked about motion of a body in the horizontal part. We've talked about motion of a body in the vertical part. Now, projectile is like a concept that combines the two. When you have a body moving in the two directions at the same time. So what is a projectile? Projectile is a body launched into the air and allowed to move freely under the force of gravity. We all know that one. Now, but what is projectile motion? Projectile motion is the motion of a body in two different directions at the same time. That is experiencing horizontal motion, also experiencing what? Vertical motion at the same time. Look at this diagram. A body launched into the air like this. Let's assume this is where the body is starting from. This is where it is launched. Let's assume you are throwing a javelin or something, you know, and you launch it into the air. It starts moving, initially from rest, and this is where it's going to hit the ground. This is where it's going to hit the ground. But let's look at the motion together. See, when the object is here, look at the horizontal distance, though. Look at the vertical. It's already having a particular height, Abby. It's going up. At the same time, it's going to the what? To the right. And if you look at the distance there, it's already here, Abby, at this point. It has covered a particular distance. Now, when it gets to this point, what do you notice? It's still going up. But it's also moving to the what? To the right. At this point, it has covered another what? Another distance. And in the vertical direction to C, it's already higher than the what? Than the last position. Then another time too is here already. Still going like this. But now, you know, at this particular point, this is what we call the maximum height. This is what we call the what? The maximum height. As the maximum height, the motion ceases to what? To exist in the vertical direction. Only in the vertical direction. Meaning, at the maximum height, this thing we have what? Zero what? Velocity. Meaning no movement at the maximum height. Then it's not like wait for a particular period, like a very short period of time. And when I throw this thing up now, it will get to a point that it will just stay momentarily. A very short period of time. Open my, like, just wait. Now, after waiting for that short period of time, what do you notice is that it will start coming down. Now, as it's coming down, what do you notice? It will start directing its direction towards this place in the vertical, but at the same time, it's still moving forward. It's still what? Moving forward. Now, when we get to this point, it's also moving forward, but now coming down until it gets to this final position. But if you notice one thing, even though this thing seems as if it's going up, the distance in the horizontal direction keeps what? Increasing until it's back at this projection plane again. Now, I know you understand to some extent what I just said, but the main part when it comes to question is identifying, okay, the motion of this thing is in the vertical, is in the horizontal. So that means I'm like, that now like make me want to like draw this table where I'm going to like analyze what formula do you need for so component of the what? Of the motion. Now see something. We have parameters that will be asked. Then we have the horizontal. Then we have the vertical. Now, see, there are some parameters that they will ask you if they want to ask question. The number one that is very, very easy to ask is what? Is the time to get to the maximum height. If you are asked to calculate the time required to get to the maximum height, How do you calculate it? In the horizontal direction, there's nothing like that. You only have that one in the vertical component. Yeah, I know some of you are having this question. What about t equals to u sine theta over g? Yes, that is an angular projection. I'm coming to that. Now, for horizontal projection, there's nothing like that. So dash. For vertical projection, we have, and that is what? T equals to what? U over what? Over g. And you know that your u is what? Is the initial velocity, and your g is the what? Is the acceleration due to gravity. If you are asked to calculate the time of flight, which is the time taken to get to the maximum height and come back to the projection plane again. See, I showed this thing up like this. The time it takes to go up and come back to where I projected it from. That is what we call the time of flight. For the horizontal direction too, no. But for the vertical direction we have, and that is equal to t equals to 2 small t, which is something as 2u over what? Over g. Now, it doesn't ask us to calculate the range. What is the range? The range is the horizontal what? Distance between the point of projection and the point at which the projection plane hits the projectile hits the projection plane again. For example, now let's assume this is the projection plane. I projected it from this place. It goes like this, then gets to this point. Now, from here to here, there's a distance in between horizontally. That's what we call the range. So what is the formula when it comes to this case? The formula is equal to R equals to what? What is it called? U square over what? Over G. Yeah. But it won't work because we are not dealing with the vertical direction. You use this one. You use what we call the UX times T. Now let me explain something. There's a difference between UX and UY. UX is the horizontal, is the initial velocity in the horizontal direction. While UY is the initial velocity in the vertical direction. So whenever you have to calculate range, and it's not an angular, it's not an angular projection, the initial velocity given is along the horizontal axis. So that is UX. Then the time taken, they will have given you, so they will tell you that okay, it takes so amount of time. So you multiply that and the time, and that will give you the range. And when do you have that kind of question, they will tell you that okay, a body is already at a particular height. It was now like maybe kicked or something. Let's assume there's this is a table now, and I want to like kick this thing to go like this. You know, I'm kicking it horizontally. That is horizontal projection. Not that I'm kicking it up or something. I'm kicking it horizontally. Are you with me? So that is when you have this kind of range. Then for the vertical side, no. Yeah, no. We don't have that. Then we now have what we call the height. The height, which is the maximum height most of the time. Usually ask for the maximum height most of the time. It's not composite, it's maximum height too. But most of the time, the usually calculate the maximum height. Now, if it is maximum height, you know, height is vertical now. There's nothing to do with that in the horizontal. But in the in the vertical, we have. And that means our h, which is the maximum height, is equal to what? U square over 2g. These are the short formula for it. And in the horizontal too, we can have, see, you know I said I kick this thing in the horizontal like this, Abby? Yes. It did not ask me to calculate that the height of this table initially, the height of this table, see, I'm kicking it horizontally. Fine, it's horizontal projection, but I'm kicking it at a particular height above the ground. If I'm asked to calculate the height above the ground, what's the formula? The h is equal to what? Square root of, not square root. Is equal to what? 1 over 2 gt square. Where the t is the time taken for the what? For the object to get kicked from this place to the what? To the ground level. Are you getting it? So this is for the horizontal and the vertical. Let's quickly talk about the the angular projection part. This is actually small. That's why I didn't write the 3 at the same time. Now, angular projection. Now, for the angular projection is the common formula that we all know. When it's time to get to the maximum height, we say our t is equal to what? That's what? U sine what? Sine theta over what? Over g. Yes, you get it. Then the time of flight is what? Capital T, which is what? 2t, and that is 2u sine what? Sine theta over what? Over g. For the range nko, we all know that one too. R equals to what? U squared sine what? Sine 2 theta, abi, over what? Over G. What about the maximum height? The maximum height H is equal to what? U squared sine what? Sine squared theta over what? Over 2G. So those are the formulas needed. You don't have to like think too much. Just read the question. Is it horizontal projection? Is it vertical projection? Is it angular projection? So whenever you determine which and which you are dealing with, then you just pick the what? The most appropriate what? Formula to use. But I want to call your attention to something. They can be very, very tricky sometimes, and I ask you for range in this kind of scenario. See, this kind of scenario is a special one. If they want to ask you, that means they want to just test your understanding of this thing. See something. I am at a particular height. Let's assume I'm on the mountain. I'm on the mountain like this, and I'm made to like I'm projecting something. I kicked it upward, and it gets projected in this form. Now, it's different from something like this. It's different from me projecting something horizontally directly. I'm on top of something, and I kicked it up. So that means this curve was not projected like this. It was projected upward first at an angle. At a particular what? Angle to the what? To the horizontal. Now, if I have this kind of question, I must not rush to go and say that my range is equal to, where can I write it? I must not rush to go and say my range is equal to U squared sine 2 theta over what? Over G. No. If I do that, it's pure zero. I must be very calm enough to what? To split the whole what? Into whole journey into what? Into two different type of what? Into two different type of journey. Which can be like this, or the one I like using the most is to split it into something like this. See, I split it to the first part of the journey like this. I say it gets to the maximum height. Now, this side is A, this other side is what? Is B. It is very easy like this. And what I do is that from here, I will calculate the time it takes to get to this maximum height, which is our first T, that is T1. Let's say to this point, that is T1. Then I will calculate the time it takes to move from this point to this point, which is what? From this point to this point, let's call that one T2. Now, I will now have a capital T, which is time of flight. You know, we said time of flight is time taken for it to move from the point of projection to the point at which it strikes what the ground be. So my capital T will now be equal to T1 plus T2. Meaning the time taken for the first half of the journey plus the time taken for the second half of the what? Of the journey. Now add it together, I'll give me T Abi. Now, I will now go back to, I will now say that my formula for range R is equal to U, which is the initial velocity which I will given, multiplied by capital T. Multiplied by what? By capital T. And since it's a, what is it called? It's an angular projection. Most of the time, it's going to be like this. It's going to be U capital T cos theta. There's actually a proofing for that, but there's no time to like start working on that. But most of the time, it's going to be like this. But if you don't want to cram, if you are the type that likes understanding, someone like me, you just have to like get, okay, the horizontal displacement is around the horizontal, right? So I will have my U what? UX. And UX is going to be what? If it is, what is it called? Horizontal projection. My UX is going to be the U given cos what? Cos theta. Abi? And if it is U cos theta, then my capital T is my capital T, Abi. Then recall that your range is equal to your U times T, Abi. From that one that we drew the other time from the table. Now, here I'm having UX, Abi. And now my US is what? Is U cos what? Cos theta times, what is my T now? I said the T is split into two. The first half of the journey, the second half of the journey, which I made capital T. That is adding everything together, multiply by capital T. Then the real formula will now become U capital T cos what? Cos theta, which is what I wrote here the other time. So this is basically the main stuff when it comes to what? Motion. We see how what we call simple harmonic motion, which I would like you to go and read on. It's not that common. These are the most common part of it. If they are going to ask questions on simple harmonic motion, there are going to be questions related to what? Statements. Yeah. Let me just tell you something about it, which they might ask. They might ask you that the acceleration of a body experiencing superharmonic motion is in which form? It's always in this form. just your A is equal to what? Minus the W square X. This formula is very important when it comes to simple harmonic motion. Your acceleration is direct proportional to what? To the displacement. And note this minus W square is a constant. But they will ask you that what is the meaning of that minus? It means your acceleration and your displacement are in opposite what? Direction. So if they ask you any question in that form, it's going to be based on this. Then whatever they are going to ask next is going to be based on maybe period, frequency, and that one depends on the formula you already know from your, what's it called? Your periodic motion, your oscillatory and all this thing. Should you get? So that is that about that. Now let me tell you something. That exam is actually not a matter of intelligence. Yes. I've seen a lot of people that have done this exam, you know, a lot of people that have like at the top of their class and they end up scoring something low. For me, if anybody asks me that, what can you tell a JAMB student? I will tell you to read, fine. But you must not underestimate the place of what? Of grace. And the only person that can give you that one is what? Is God. So when it comes to what? To you preparing for this exam, read as if no one is coming to help you. And also what? Count and depend on God and pray as if God himself is the one that should come and write the exam for you. And you know one thing? He said, ask and it shall be given unto you, Abi. Seek and ye shall find, Abi. So ask. Ask him. He's not deaf. Just always ask. Tell him, God, I'm already reading. Give me this understanding. Let me be better. Give me that excellence. Let me be 10 times better than my peers. Just the way Daniel was what? 10 times better than his what? Than his peers. So, that is what I will leave you guys with. My name remains Pelumi Ogule. Thank you.
Be sure to link up with us, message us, seek out for our email, send us messages for further questions and mentorship after you have seen these videos. I'm very happy to say this again, that it's a time for you to move on and succeed. It's a free success project 2025. Bless you everywhere that you are. Again, my name is Emmanuel Aderoju Adeyemo from Creative Mind Concept.